Hello everybody, welcome to Visual Learning Portal where visuality conveys best. Let's do further questions of trigonometry. So, in the question we have, if secant theta is given 13 divided by 12, calculate the other trigonometric ratios. So, what are the basically other trigonometric ratios? Which are, if there is a secant theta, means we still need to calculate the other trigonometric ratios, which is sin theta, cos theta, tan theta, secant is already there, so cot theta and cosecant theta. So, means 5 other trigonometric ratios if one is given. That's not at all hard. So, how to do it? Let's see that. Okay. So, we have, first of all, we need a triangle for this one. So, let's draw the right angle triangle. So, here we go. So, that's the right angle triangle. Okay. Now, in the right angle triangle, we're going to assume let it be A, B and C. So, we're going to take it, let's take this as A, let's take this as B, let's take this as C. And this is a right angle triangle. And also, and it's right angle at B. And there is a theta, you're going to assume theta as this. Okay. Now, as we have given the secant theta and we know that secant theta is equal to 1 over cos theta. So, you already know that cos theta, what is the value of the cos theta? Cos theta can be written as adjacent divided by hypotenuse. But if you need to write 1 divided by that, basically what you need to do? You need to flip the term. Flip the term, you are going to write hypotenuse here at the top divided by adjacent. Okay. So, the values are already given to you, which is 13 divided by 12. So, you are going to write at the hypotenuse 13 here because this is the longest side and this is called the hypotenuse side. Adjacent side to theta will be this one, which is also called the base, and you are going to write 12 for this one. Okay. And now it's time to find BC. Basically, BC you need to find, and we can write for this one as AC divided by AB. And our target is to find BC. How we can find the third side if 2 you already know. Remember the formula we're going to use, the Pythagoras theorem. So, let's do that. So, we're going to write for that one using Pythagoras theorem. So, I'm going to write THM for the theorem. Okay. So, we have the formula hypotenuse square is equals to opposite side square plus the base square or the adjacent square. Okay. So, hypotenuse is AC. So, you're going to write AC whole square is equal to opposite side to the theta is BC, which we are going to find, and AB, which is the adjacent side whole square. AC is given as 13, you're going to write 13 square, and BC you are supposed to find, you're going to write square, and AB is 12, so you're going to write 12 square. So, 13 times 13, learn the squares. 13 times 13 is 169, which is equals to BC whole square. 12 times 12 is 144. Now, it's time to take 144 to this side of equal to so that you can find the value of BC. And when you're going to move the positive term to other side of equal to, it will become negative. So, 169 take away 144, which is equals to BC whole square. 169 take away 144, you will get 25. 9 take away 4, 5. And 14 take away, 16 take away 14 gives you 2. So, 25 is equals to BC whole square. Now, it's time to find only BC value, not BC whole square. What are you going to do? Move the square to other side of equal to it and it will become a square root. So, you're going to write BC is equals to square root of 25. What's the square root of 25? BC is equals to 5 times 5 is 25. So, you can write for this one 5 square, and square root can cancel each other. Okay. So, you got the value of BC is equal to 5. So, you can write here the value of BC which you have calculated comes out to be 5. So, that was a question mark before, that you are supposed to find the value of BC so that you can find the other trigonometric ratios, and now you got it, which is 5. With which formula? Always remember, Pythagoras theorem always helps to find that value. Okay. Now, it's time to find the sine, cos, tan, cot and cosecant. For that, we are going to draw a triangle again. And we are going to write the values so that we can write the values again here. So, we have for that one, so we are going to draw the triangle on this page, and here is a triangle. So, you are going to write the values So it was A, this was B, this was C, this is 90 degree, that was 9 theta, this was 13, this was 12, this was 5, which we got it. Okay, so I'm going to check it. So 13, 12, 5, 13, 12, 5, CBA. Okay, now we already got secant theta is equal to 13 by 12. So you're going to check that. Secant theta 13 by 12. Now it's time to find the sine theta. Sine theta will be equals to, as you know, sine theta is equal to hypotenuse, which is the longest side. Hypotenuse, it is not hypotenuse basically, it is the longest side will become at the bottom. It is perpendicular, or you're going to say the opposite side. Opposite side is to the theta is BC. You're going to write BC divided by hypotenuse is AC. This is equal to, so BC you're going to write for the BC 5 and AC is 13. So 5 over 13 you got the value of the trigonometric ratio, which is sine theta. Similarly, you're going to find for the cos theta, which is equals to adjacent divided by hypotenuse. So for the adjacent you can write BA divided by hypotenuse is AC. BA is 12 and hypotenuse is 13. Similarly, you can find tan theta. Tan theta is equal to opposite divided by adjacent. So opposite is the side which is BC and adjacent is BA. So you're going to write for this one 5 divided by 12. Now you need to find cosecant theta, which is equals to 1 over sine theta as well. So you're going to flip the term for the sine theta. Sine theta is opposite over hypotenuse. So this will be hypotenuse over opposite. So hypotenuse is AC. Opposite side is BC, which is AC, and this is BC. Okay. Now last with cot theta. Cot theta is 1 over tan theta. So whatever the values you got for the tan theta, you need to flip that. So you're going to write adjacent over opposite. So for the adjacent over opposite, adjacent is BA and opposite side is BC, which is equals to 12 divided by 5. So these are the all other trigonometric ratios. So once you know all the sides of the triangle, basically the right angle triangle where the actual Pythagoras theorem works, you're going to find all the other values, all the other trigonometric ratios. Thanks for watching Visual Learning Portal.
Any questions? Comment below and we'll respond as soon as possible. Don't forget to hit the subscribe button and press the bell icon to be notified when we release new content. We'll keep posting as much as we can. Thanks for watching.